Yeah, in this video we are going to discuss NumPy broadcasting, which is a concept related to vectorization, which we discussed in the previous section. So the concept of vectorization and ufuncs in NumPy. So broadcasting is just something that happens behind the curtain of NumPy. So it's nothing we have to worry about by ourselves. It just happens, let's say, as a magic thing in the background. So by that, for example, if we recall the vectorization example from the previous video, where we had a NumPy array, let's say the NumPy array was 1, 2, 3, and we wanted to add the scalar 1 to every element. So we performed this operation here, and what happens behind the curtain is that NumPy will create an array implicitly that has the same shape as this array to the left, and then it will add them together. So by that, what I mean, if I have my array A, which is 1, 2, 3, and I add 1 to it, add 1 to it, what happens in the background is that it will actually do something like a plus NumPy array 1, 1, 1 implicitly, because yeah, this would be the proper linear algebra notation. In linear algebra we can't just add a scalar to a vector because the dimensions don't match, so this would not be a valid command or operation in linear algebra. However, NumPy allows us to do these things because implicitly it's actually doing this one. But yeah, you don't have to worry about the exact details how it does that in the background. I'm just saying NumPy is allowing you to do some things that are not possible in regular linear algebra. However, it makes our life more convenient because doing this one here is way more convenient than creating a second array, right? So in that way, it's kind of cool that it allows us to do things that are not possible in linear algebra. And yeah, funny enough, I recently got back a review of a deep learning paper where we also in deep learning, it's also common that you add a vector to a matrix. So what happens is if you have a column vector and you add the vector to the matrix, it gets added to each column. However, in linear algebra, this would of course not be a valid operation, but in the field of computer science and deep learning and machine learning, it's quite common to write it like that because it's just shorter. And yeah, the reviewers were actually noting that this is impossible in linear algebra. And yeah, I could tell then that this reviewer was clearly not a deep learning person. Anyways, let's not get distracted by that. Yeah, and I think, yeah, I just see it's a very short video. So the last example here is showing you exactly that, what I just coincidentally talked about. So here we are adding an array to a two-dimensional array, which can be considered a matrix. So you can consider this as a vector and this as a matrix. So what will happen is that it actually works by creating this implicit dimension here. So recall array 1 was just a vector. Oops, didn't even execute it. Where? I haven't even defined it. Anyways, so let me just quickly define it. 1, 2, 3. So we can execute it here. So yeah, we can see now this works actually. We are adding this vector to this two-dimensional matrix, and due to broadcasting, it's actually creating this implicit dimension here and adding those two together. Okay, so but that's it for this video. In the next video, we will talk a little bit more about advanced indexing, which is also called fancy indexing in some contexts. And then we'll also talk about very important concepts like memory views and copies, because this is something that can easily trip you up in practice when you don't know sometimes whether you created a copy or a view onto an array. It can easily happen that you overwrite values accidentally. So the next video will be again a more important one.